area. I would want to get back to Bob's question, though, and it does seem to me that emphasis on hypothesis testing, the Neyman-Pearson framework, it is really pretty prominent in how statistics is taught, at least in how I was taught, although that was a long time ago. And certainly what I see from new trainees also. That would certainly be one way of changing how we do the teaching of statistics. So are there additional comments about the teaching question? And I think Arlene Ash has her hand up. Arlene, can you give us your comment?
Yes. So this is part of a long discussion about the mindless way in which people apply the rules, and a lot of frustrations that many of us feel when we submit papers and some reviewer tells us, you know, P equals 0.051, you can't talk about that, it's not real. I found an article that I liked a lot that I'm going to try to post when I get the opportunity. I was trying that earlier and couldn't do it right now. But the title of it is, Do We Really Need the S Word, where S is statistical significance? And it argues, I think quite correctly, that when you have a word that has an English language meaning that is quite different from its technical meaning, it's very hard for these concepts not to leak over one into the other. And I think we have some historical reasons why people used to report things as P less than 0.05, and that's because they were looking things up in tables in which you really couldn't determine exact p-values. You could just see whether something was on one side or another of a fixed number of cut points. So at a minimum, I think that people have to get to the place where we tell folks, if you're going to report a p-value, you should report the exact p-value, although if you're talking about a large group of things, then you can indeed talk about this is the set of things which has certain thresholds. The article, Do We Really Need the S Word, basically says that we should, just try to purge that language and talk about, just try to describe the strength of our findings and use things like p-values in a descriptive sense to help us say there seems to be more of a signal here than there. And I'd like to try to, in teaching, say to students, to the extent that you can actually write sentences that describe your understanding of what the finding means, that's going to always be preferable to just following some rule that says you can't even talk about it if P isn't, it's a finding if P equals 0.049 and not if P equals 0.051. As for the multiplicity problem that Knut has talked about, and whether we should be paying attention to 10 to the minus 7.5 or something different, that's of course the same problem that we come into when people are saying with multiple comparisons, should we use a Bonferroni correction? Should we use something else? And I kind of hold with people who say, if you're going to compute a p-value, it at least is something which has a very clear meaning, then you should report the singleton p-value in addition to anything else that you do to put it in context. So it's perfectly okay to say, even though this p-value was 0.01, which you might normally think means something, you have to remember it in the context of the fact that we did 200 tests or 2 million tests or whatever. So that's a few thoughts.
Okay, yeah, I think that certainly relates to how statistics is taught. And again, I would say the theme is that, more emphasis on conveying the amount of evidence and less on making automatic decisions would certainly be very helpful, and steer students away even at the start from dichotomizing the study's results as opposed to